So this video is to show you a pretty important idea in statistics, which is that the binomial distribution and the normal distribution under certain conditions actually look very, very similar. So I have my in-class students do an exploration with this little online tool here. It's going to show us the probability distribution for binomial distributions. So n is our sample size. Let's start with a pretty simple sample size, say 10, and we'll do a probability of 0.5. And I could enter x and it would give me the calculations. We really only care about the approximate shape of the distribution right now. So the criteria that we actually will need in order for a binomial distribution to be approximately normal is that we want n times p to be bigger than or equal to 5, and n times 1 minus p, or the complement of p, to also be bigger than or equal to 5. So right now, I have that n times p and n times 1 minus p are both equal to 5. And you can see that this is looking approximately like a normal distribution. So we could theoretically approximate it with the normal distribution centered at 5 and a standard deviation of 1.581. You could calculate the actual, or you could then use that to approximate with a normal distribution. So just to illustrate, what if we do not meet those criteria? And the more extreme we get, just the worse these approximations become. So for our probability, I could say 0.4. Technically, this would not qualify because 10 times 0.4 is 4. It would be under our criteria. You can see this has a little bit of a right skew. There's a little tiny bit of probability here. It's very small and hard to see. And as if I were to let this p-value get smaller, becomes more prominent of a skew, 0.25, even more prominent, 0.2, even more prominent. And if I were to let my trials now increase, however, so say I made this 40. Now it starts to look a little bit more approximately normal. This one still has a little bit of a skew here. And if I make this, say, 100, now we're starting to look fairly normal, even though our probability is pretty far away from kind of being balanced. It ends up being approximately normal, and you can approximate it with the normal distribution with a mean of 20, which is the expected value of this binomial distribution, and a standard deviation of 4. That calculation, again, is the square root of n times p times 1 minus p. When we use proportions in the future, you remember I said that binomial distributions will help us model when we're doing inferential statistics on proportions. So it's important to make sure we have this understanding of the connection between binomial distributions and how approximately normal they are. See you in the next video.